Okay students, in today's class we will discuss about a cell. What do you know about a cell? The most important thing you need to know about a cell is that a cell is a source of energy. The most important idea you need to understand about a cell is that a cell is a source of energy. You know different types of cell. One type of cell is called electrochemical cell. The second type of cell is called a solar cell. Just some examples of cells is what I am just meaning here. We will be studying different types of cells in this year. One of cell is electrochemical cell. What does an electrochemical cell do? An electrochemical cell will convert chemical energy into electrical energy. Some examples we say simple voltage cell, Daniel cell, Leclanche cell, lead acid accumulator, nowadays lithium ion batteries. This is what is called electrochemical cell. It's a cell which convert chemical energy to electrical energy. Then another type of cell we have to say is called a solar cell. What is a solar cell? Something that finds a lot of applications nowadays. It is one of the renewable source of renewable source of energy. A solar cell is a device which converts solar energy to electrical energy. Solar energy is getting converted to electrical energy. A few examples is what I mean here. What are the basic components of a cell? Basic components of any cell. The components of a cell. What are the basic components of a cell? A cell basically consists of two electrodes. One is a positively charged electrode. The other one is a negatively charged electrode. Then an electrolyte. Electrolyte. It's a medium which transfers charges, or which allows the flow of, or which allows a current through by means of flow of ions. A medium which allows the flow of, which allows current by means of the flow of ions is what is called an electrolyte. And the symbol of a cell is something like this. This is the symbol of a cell. This is a positive electrode. This is the negative electrode. Okay, now we have to study some important terms associated with a cell. The first two terms we are going to discuss is regarding what is called EMF. What do you mean by EMF of a cell? EMF, electromotive force, but it is not a force. Although we say electromotive force, but electromotive force is not a force. What do you mean by EMF of a cell? It is the potential difference between the terminals of a cell. When terminals are not connected. It is the potential difference between the terminals of a cell when the terminals are not connected. This is what is the definition of EMF of a cell. Let us understand this. Let us consider a cell. Let us consider the positive electrode of the cell. This is positive electrode. This is the negative electrode. And we have got an electrolyte here. This is just a simple representation of the cell only. When you study in chemistry, you will find something extra. Let us us consider 2 points A and B in the electrolyte. A and B, 2 points in the electrolyte. When terminals are not connected, please understand carefully. When terminals are not connected, I have to say VA is equal to VB. When terminals are not connected, that means there is no current in the circuit. When there is no current in the circuit, the points A and B are at the same potential because the circuit is incomplete and there is no flow of charges taking place, which means A and B are at the same potential. Ready? A and B are at the same potential. Okay. Now let us call this as P and let us call this as N. Let Vp minus Va, the potential of the positive plate with respect to electrolyte. Potential of positive plate with respect to electrolyte is V plus. Vp minus Va is equal to V plus. V plus, that is potential difference between the positive electrode and the electrolyte. I said let Vp minus Va is equal to V plus. The potential difference between the positive electrode and the electrolyte is V plus. Similarly, Vn minus Vb is equal to V minus. Minus V minus. That is the potential of the negative electrode with respect to the electrolyte. The potential of the negative electrode with respect to the electrolyte is minus V minus because negative electrode means it has got negative charges. Negative charges means its potential will be negative. Positive charge, its potential is positive. So electrolyte we are assumed to be at, if electrolyte is at 0 volt, this will be V plus and this will be minus V minus. Okay. Now what is the definition of EMF of the cell? It is a potential difference between the terminals of a cell. Potential difference between the terminals of a cell. The EMF epsilon is equal to Vp minus Vn. That is the definition, right? It is a potential difference between the terminals of a cell. Potential difference between the terminals of a cell when the terminals are not connected. Which means the EMF epsilon is equal to Vp minus Vn. May I write this as, this is Vp minus Va minus Vb minus Vn. Vp minus Va. Now you look at this expression, look at this step and look at this step. Now question is, this is Vp minus Va minus Vn minus or minus plus Vb minus Va plus Vb, they will be cancelling. Now what is Vp minus Va? Vp minus Va we already got, this is V plus. What is Vn minus Vb? Which is minus V minus, which means minus V minus. Which means what is the definition of EMF of a cell? EMF epsilon is equal to V plus V minus. Which means the effective EMF of a cell is equal to the magnitude of the potential of the positive electrode plus magnitude of the potential of the negative electrode. Or simply absolute values of V plus and V minus you can add to get the total EMF of the cell. This is the definition of EMF of a cell. What is EMF of a cell? It is a potential difference between the terminals of a cell when the terminals are not connected, and so EMF E epsilon is equal to V plus V minus. And please understand that EMF of a cell is not a force, but it is potential. And what about a cell? A cell is a source of energy. It is not a source of charge. Please understand that. Now we will consider the next idea, that is internal resistance. This is very important, I have to say. Internal resistance. Internal resistance. What do you mean by the term internal resistance? Internal resistance. Internal resistance is very simple. Everything in physics can be learned very easily if you just mean it in the correct sense. Internal resistance. What is internal resistance? It is the resistance of a cell. Internal resistance means it is the resistance of a cell. It's a resistance offered by a cell, that is more correct. Resistance offered by a cell. The resistance offered by a cell is called internal resistance. What are the components a cell contains? A cell contains electrodes. So on what factors internal resistance of a cell depends? Factors on which the internal resistance depends is one, nature of electrodes. The factors on which the internal resistance depends. It's very important in the board exam point of view. It depends on nature of electrodes. Then it depends on separation between electrodes. It depends on nature of electrolyte. The internal resistance depends on nature of electrolyte. In the nature of electrolyte, it depends on concentration of electrolyte, purity of electrolyte. All such things will take into consideration. And finally, temperature. Finally, temperature. Internal resistance of a cell depends on temperature. How? I cannot explain. It depends on temperature. It may increase or decrease with rise in temperature, because then these factors also will come into play. So what is internal resistance? It is a resistance offered by a cell. On what factors the internal resistance depends on nature of electrodes, that includes the purity of electrons, etc. Then separation between the electrodes. How much the electrodes are separated also determines the internal resistance of the cell. Then purity of electrolyte, concentration of electrolyte, altogether I said nature of electrolyte, and finally temperature. Now we will consider the next idea, that is regarding terminal potential difference. Terminal potential difference. What do you mean by terminal potential difference? Let me explain this. This is the potential difference between the terminals of a cell when terminals are connected by means of a resistance or load. It is the potential difference between the terminals of a cell. Read this definition clearly. The potential difference between the terminals of a cell when the terminals are connected by means of a resistance or a load. Load means a device. Okay. Now that is the definition of terminal potential difference. Now let us consider a situation. Okay. This is the symbol of a cell with the internal resistance. The EMF of the cell is epsilon. The internal resistance is small r. And let me connect it by means of an external resistance, capital R. Okay. Now this much is nothing but our cell. This much is nothing but our cell. Let me take this point as A. This is the positive terminal of the cell, right? Positive point A represents the positive terminal. Point B represents the negative terminal. Point A is the positive terminal, point B is the negative terminal. Then I can say this point is also A and that point is B, right? Because they are joined by the same conductor. A conductor is an equipotential body. Now let us find out the terminal potential. Okay. So according to Ohm's law, I can say VA minus VB is equal to capital I into R. Why? Because this is a resistance R and the potentials of terminals A and B, which are the two ends of the resistor, which are VA and VB. So VA minus VB is equal to I into capital R. That is one expression for terminal potential. Please understand. This is also equal to the EMF of the cell is epsilon. The voltage drop inside it is I into R, which means epsilon minus IR. Very simple to പറയാം. For this purpose I am using മലയാളം. എൻ്റെ കയ്യിൽ എപ്സിലോൺ എന്ന് പറഞ്ഞൊരു EMF ഉണ്ട്, അല്ലെങ്കിൽ ഇത്രയും രൂപ എൻ്റെ കയ്യിൽ ഇരിപ്പുണ്ട്. ഞാൻ സ്വന്തമായിട്ട് എത്ര എടുത്തു? IR എടുത്തു. കാരണം ഈ റെസിസ്റ്റൻസ് ആറാണ്. IR ഞാൻ എടുത്തു. ഞാൻ എത്ര പുറത്തേക്ക് കൊടുക്കും? എപ്സിലോൺ എൻ്റെ കയ്യിൽ ഉണ്ടായിരുന്നു, IR ഞാൻ എടുത്തു എൻ്റെ ആവശ്യത്തിന്, ബാക്കി ഞാൻ എത്ര പുറത്തേക്ക് കൊടുക്കും? പുറത്തേക്ക് കൊടുക്കുന്നതല്ല ടെർമിനൽസിൽ കാണാൻ പറ്റുള്ളൂ. അപ്പൊ എപ്സിലോൺ എൻ്റെ കയ്യിൽ ഉണ്ടായിരുന്നു, IR ഞാൻ എടുത്തു, ഞാൻ എത്ര ബാക്കി കൊടുത്തു? Okay, now I will say the same in English. I had epsilon with me in my pocket. I used IR for my internal affairs. Then how much I will be able to provide to others? Epsilon minus IR, that is the terminal potential V is equal to I into capital R, which is equal to epsilon minus IR. This is the case of a discharging cell. This is the case of a discharging cell. Who is a discharging cell? A cell which delivers energy is called a discharging cell. A cell which delivers energy. So for a discharging cell, please understand carefully. For a discharging cell, the direction of current is always directed away from the positive terminal. For a discharging cell, current is always directed away from the positive terminal. Got it? Current is always directed away from the positive terminal for a discharging cell. Now, I can just relate these two. Epsilon minus I into small r is equal to I into capital R, which means epsilon is equal to I into capital R plus small r, right? This you have to take to the other side. Sir, that is very simple is what you will say, because these two resistors are connected in series and effective resistance when resistors are connected in series is capital R plus small r. So current I is equal to, which gives current I is equal to epsilon divided by capital R plus small r. This is the expression for the current I in case of a discharging cell. Now in this case the terminal potential V is equal to I into capital R. V is equal to I into capital R, which is equal to epsilon into capital R divided by capital R plus small r. This is the expression for the terminal potential of a discharging cell. Terminal potential for a discharging cell. What is capital R? The external load resistance. What is small r? The internal resistance of the cell. Small r is the internal resistance of the cell. Now we can see that if you plot, so we will plot a graphic, we will have the graphical representation for terminal potential versus I and terminal potential versus capital R. First graph I am going to write is terminal potential versus I. Now we have the formula for terminal potential V is equal to epsilon minus I into small r. Which means if I plot a graph between V and small r, what will be the shape of the graph? The shape of the graph is going to be something like this. This is the shape of the graph. Shape of the graph will be a straight line, because this equation is of the form minus IR plus epsilon, which is Y is equal to mx plus C. Now the potential of this point will be epsilon. Sorry, this is not R, this is I, my mistake, I. This is V. And the current corresponding to this point will be epsilon divided by R. This is the current corresponding to this point, because at this point V is equal to 0. At this point V is equal to 0, which means 0 is equal to epsilon minus IR. And that means I is equal to epsilon divided by small r. And please understand one more thing, that the slope of this graph is minus r. Slope of this graph will be minus r, or magnitude of the slope will be r. Then you may be asking the question, sir, can the resistance be negative? Resistance cannot be negative, but slope will be negative only. The slope of this graph is negative, which means negative quantity is equal to minus r, or I am getting r as a positive quantity. This is one graph you have to understand. The second graph was asked for this year's CBSE board examination. The variation of terminal potential. The second graph is V versus capital R. V versus capital R. That is V versus the external load resistance. We got terminal potential V is equal to epsilon R divided by capital R plus small r. Ready? Now it means I can just write this equation as epsilon divided by 1 plus small r by capital R. What I did here, I divided both sides with the capital R. In that situation, terminal potential V is equal to epsilon divided by 1 plus small r by capital R. Now, what will be the shape of the graph? Let us see. Terminal potential V versus capital R. Okay. When capital R is equal to 0, again, let us see from this equation itself. When capital R is equal to 0, this term becomes infinity, the denominator becomes infinity, or V is equal to infinity, 0. Hey, no need to see that. V is equal to IR is enough. When capital R is equal to 0, V is equal to 0. Now you can see this graph is not a straight line because this term comes at the denominator, small r is at the denominator. The shape of the graph will be something like this. It won't touch because under what condition, for what value of capital R, V is equal to infinity. For what value of capital R, V is equal to E. I'm sorry. For what value of capital R, V is equal to E. You can see from this equation. When capital R is equal to infinity, capital R is equal to infinity, R, small r by capital R becomes 0, 0 plus 1 is 1, that is epsilon 1 by 1. I repeat, when capital R is equal to infinity, small r by capital R is equal to 0. Because small r by infinity, that is equal to 0. Small r by capital R is equal to 0, then 0 plus 1, 1, that is V is equal to epsilon. So this is a very important graph. This is a curve you have to understand. This is the graph between the terminal potential V and the load resistance capital R. This is for a discharging cell. This is the situation for a discharging cell. Now let us consider the next idea, that is cell kept for charging of a cell. Charging of a cell, you know it. You know how to charge a cell. You are all using mobile phone and you are charging it every day, you are discharging it every day. Now you'll be discharging only. Now how we can charge a cell? Okay, let us consider a situation. This is a cell of EMF epsilon 1. And I want to charge a cell of EMF epsilon and internal resistance small r. Okay. Now the important thing you have to understand is that epsilon 1 should be greater than epsilon. This is the most important thing. When one cell, okay, let me call this as the source cell and this is the charging cell. Source cell and charging cell, the most important requirement for charging a cell is the source must have higher potential compared to the charging cell. Now in this case, I consider the source cell to be ideal. That is why I am taking its resistance to be negligible. Let us take this point as A. Let us take this point as B. The current is directed in this way. So what is the difference between the previous two figures? Discharging. In case of discharging, what we have seen is that the current is in this direction. That is directed away from the positive terminal. In case of charging of a cell, you can see the current is likewise. See this? See this? So this is the important condition you have to understand with the discharging of a cell and charging of a cell. Discharging and charging, you have to understand this idea. Now tell me what will be the terminal potential here. If I say this is VA minus VB, that is the terminal potential. In this case it is epsilon 1 for the top cell. The other thing is going to be epsilon minus IR. Why this minus IR? You can see here. Look at the difference between the two figures. Look at the difference between the two figures. Earlier case it was epsilon. Here V is equal to epsilon minus IR. Here V is equal to epsilon minus, I say minus IR. What is the reason for this minus? Look at this figure and tell me what is the reason for this minus. Minus. Look at this figure. You will easily understand it. What is the reason for this minus? Reason for the minus. Reason for the minus. Current is reversed in this direction, right? Current is reversed. So in this case, the terminal potential V is equal to epsilon plus IR. The terminal potential V of a charging cell is epsilon plus IR. The terminal potential of a discharging cell is epsilon minus IR. I repeat, the terminal potential of a charging cell is epsilon plus IR. The terminal potential of a discharging cell is epsilon minus IR. Epsilon minus IR. Charging epsilon plus IR. Discharging epsilon minus IR. Charging epsilon plus IR. Discharging epsilon minus IR.